Welcome to this short presentation where we will go through a few examples of using the Blueback Well Data Viewer to examine well log content before doing well log data analysis. A common practice when building data analysis plots for well logs is to turn on all the log properties that we want to analyze and then turn on all the wells in the project. We don't bother checking what wells actually have the data that we're analyzing, and that can cause some confusion when we run calculations based on the data analysis and we go to a certain well to explore the new data. We don't understand why this new generated result is missing. This kind of confusion can be avoided by doing examination of well log content before we go to the data analysis steps. The Well Data Viewer in the Blueback Unconventional Toolbox is a very efficient tool to use for this examination. In the Global Well Logs tab, it is very easy to identify groups of wells based on well log content. So here in the Global Well Logs tab, we simply highlight the combination of logs that we want to analyze, and then we highlight the wells, identify the wells that has this combination of well logs, and then we can populate those wells into a Petrel window, and from here it's very easy to generate the data analysis cross plots, histograms, and so on. So now we will go to Petrel, where I will show two examples of examining well log content before we go ahead with the data analysis. So here you see my Petrel project. We've got more than 4,000 wells in here, and we've got a lot of different logs, so you can see it is very well worth it going in and doing this kind of well log content analysis. What wells actually have what logs before we go in and do any kind of data analysis, because otherwise we just end up adding many wells that doesn't have any of the logs or part of the logs that we want to analyze, and that is that's frustrating. So the first example I want to show you, a very short example. We've got some Petrophysical calculated porosity and perm logs, and then we've got some core porosity logs and core permeability logs. So we want to build an investigation where we can go in and compare the calculated versus the core logs. So we go to the Well Data Viewer. It opens up here in a few seconds, and then we go straight into the Global Logs tab, where we can refresh the well count per global well log. So now it is calculating how many wells are present for each of the global well logs in the project. And we can go in and look at the porosity and permeability log that we want to look at is present in 4001 wells, so that is present in almost all the wells. But the core porosity and core permeability logs are a little bit more sparse. So we have the core porosity is present in 464 wells, and the core permeability is present in 490 wells. But who knows if these are actually almost all the same wells. So what we do here is we go in, we highlight the well log properties that we want to do analysis on, and we identify the wells that has all of these four logs present in them, and these wells are now highlighted here in the well list, and we can see that all the wells that has these four logs present is 181 wells. So to build the investigation from here, we populate these wells into a Petrel window like this. We go in and display the logs that we want to do analysis on. So, and we add the zone logs because that is very nice to have. Then we go here to the Petrel Windows tab, create Blueback investigation, and we want to generate a cross plot. So we'll call this investigation pour perm. Hit OK, and now the building of the investigation is running in the background, and pretty soon we will have a cross plot where we can go in and do analysis of this petrophysical calculated logs versus the core logs that we have. So see your permeability versus permeability 1, which is the core, versus the calculated permeability, and it's very easy to go in and change the different data types on the axis, as you know. And we can go in here and just look at certain zones in our logs. So you see that now in this investigation, in this data plot, we are absolutely sure that these 4 logs are present, and we only display the 181 wells in this investigation. And if we generate any regression lines or calculate any results from this, any resulting logs, we are sure that we will only be doing it for the 181 wells. Next example I want to show you guys is some elastic logs that we have. So here in this well section window, you see we've got VP, VS, and row displayed in a few wells here. And now we want to go in and do the same kind of well log content examination. So we go here, we can see VP, VS, and row is present in 127 wells, and I'm pretty sure these 127 wells are the same, but just to be sure, we highlight all the wells that has these 3 logs in them, and then yeah, that is 127 wells. So we do the same little exercise, populate those into a Petrel 3D window. We again display our zone logs and the 3 elastic logs. Go to the Petrel 3D window, and this time we will open up a matrix plot window. We'll call this elastic, and now again the investigation is being built, and now we will have these logs displayed in the matrix plot window, where all the continuous logs in the investigation is cross-plotted against each other in this multi 2D cross-plot window. So we'll just take out X, Y, and depth. Maximize this window so we can see what is going on. Let's just color by dataset instead. So here we have VS versus VP, density versus VP, and density versus VS. And we can color by zone log. And in this examination, we just want to look at our reservoir interval. So we go in here to the well section window. We can see our reservoir is zone D and zone F. So we go back to the matrix plot window and just filter out zone D and zone F. So here we have VP, VS, and row data displayed for zone D and zone F in 127 wells, we think. So let's try and go in, and now we want to generate, we do our data analysis steps, regressions, and so on, filtering data, identifying outliers, eliminating those, etc. And then we go in and we want to generate some results based on this. So we can go to the reservoir characterization plugin and generate extended elastic impedance and acoustic impedance logs and so on. So here you see we've loaded the 127 wells into the seismic reservoir characterization plugin. We have loaded the VP, VS, and row. And now we want to play around with the chi-angle to generate a extended elastic impedance that is mimicking a V-shale log. So we go here, over here, the V-shale log in a test well, well 12, is displayed in black. And now we can play with the chi-angle here. So we're not going too much into detail with this chi-angle analysis. This is just a quick example. So see, this is not a good fit. So We'll just try something else, something like this, and now we have something. The match is not 100%, but it looks a lot better than before. So we go to output. We want to generate extended elastic impedance, acoustic impedance, and gradient impedance. And we'll give it a suffix, demo, whoops, demo, hit OK, and now it'll calculate these 3 logs in those 127 wells, and we can go back to the well section window. You can see those logs were generated. They sit here at the bottom of our global well logs list, and we can toggle them on: extended elastic impedance, acoustic impedance, and gradient impedance. And we see in the first 10 wells of these 127 wells that we identified, I've displayed those here in the well section window, and we can go through and now look at the results of this calculation in our reservoir intervals. We go through the wells here, and whoops, what is that? Didn't I do this examination of the well? So this well 14 is highlighted here in my well data viewer as having these 3 logs present. And why don't I see any results? So we go here to the VPS track. We see that it is present, but there's no data. But the data actually sits up a little shallower, so that means that the VP log in these wells here is actually not present over our reservoir interval. So what do we do about that? We'll go back to the well data viewer, the global well logs tab, and again we highlight VP, VS, and row, and here's an extra little very useful filter. We can go in and tell the tool to also look at interval presence. So we'll ask the tool to identify what wells has these 3 logs present in them, and the logs have to be present in our reservoir interval here between top D and top G. We hit highlight wells with selected logs, and now you can actually see, all right, we actually only have these 3 logs present in the reservoir interval in 61 wells. So and then we can go back and do the same exercise of populating into a patrol window and building the investigation, so that we're sure that what we are doing analysis on, we know what wells this data is present in. So in these examples, we've seen that examining well log data content before building data analysis plots should be a standard exercise every time, and we've seen how easy and efficiently this is done in the well data viewer. So I hope this was useful, and thank you very much for watching.